Hi, Year 10s. We're going to talk about how you can solve trig equations. Trig equations are like normal equations, where you've got x equals 3, or x equals root 2 over 2. But instead of x, you now have cos. That's all the difference. When we've got a trig equation, basically what we're actually saying is what is the angle, theta, that gives me root 2 on 2 as my x value. So if you look on your unit circle, root 2 and 2 goes about there. Okay, and if we look at the x values where you have root 2 on 2 are that one and that one. We've got root 2 on 2, root 2 on 2, that's the coordinates of that point, that's the coordinates of that point, and hopefully you can follow on with your unit circle as we talk through this. So we're saying what angle gives us that? Well, obviously this angle in here, so theta equals 45 degrees. And also it's the angle all the way around to there, if we look at that. And that angle is 315 degrees. So we've got two angles, but also we haven't been given a restriction on the value of theta. I could start here and go all the way around to the start and then keep going. And then I could start at this, or I could start at this red one here, right here. So I could go all the way around to this one, then I could keep going and get back to there, then keep going and get back to there. So we could keep on doing all those revolutions, and they're still all angles. They're really big angles, but they're still angles. So what we do is we put plus k 360 degrees over here, plus k 360 degrees. What that's saying is it works for any multiple of 360 degrees, it still works. Okay. Now we've got this one down here, tan of theta plus 1 equals 2. Just relying on us understanding that tan of theta equals sine of theta over cosine of theta. So tan of theta, if we go, it equals plus 1 equals 2, tan of theta is just going to equal 1. So that occurs, tan theta equals 1 occurs when sine and cosine are the same, exactly the same. There's only two places that can be. That's either there, at root 2 on 2, or down there, where we've got both of the x and y coordinates as negative root 2 on 2 and negative root 2 on 2. So, just to recap, tan theta equals 1 means sine theta over cosine theta equals 1, which means sine theta must equal cosine theta. The only places that occurs is when the x and the y coordinates are equal to each other, which are at this point and that point. So that's what I'm talking about there. So therefore, that again occurs when theta equals 45 degrees. But in this case, you'll be able to see from your unit circle diagram, the second angle actually occurs at 225 degrees. And again, we have to put a restriction on there that we don't have a restriction on there. Theta can be any value. So in this case, what we can notice is that if we start at 45 degrees, every time we go around 180, we're going to get back to the same value. So we can do 45, 225, or we can just write it like this. 45 plus k2 pi, 225 plus k, and 2 pi is referring to 360 degrees, so let's just, I'll use 360 degrees. So 45 plus k 360, 225 plus k 360, referring to the revolutions, and the fact that the angle is going to be the same at every revolution. Or you could write it as theta equals 45 degrees plus 180, plus k times 180, which means every 180 you're going to get the same value, you're going to get the right value for theta, and that would take into account the fact that every tan value repeats itself every 180 degrees. So then you don't have to put the two angles, you don't have to put 45 and 225, you can just put one of them. Okay, hope that makes sense. Alrighty, let's keep going. So 12 sine theta plus 6 root 2 equals 0. This time we actually have a restriction, as you can see here, so we're going to have to take that into account. Well, don't be scared by this. Solve it as you would a normal equation. If you had x there, how would you solve it? Well, you'd get rid of the 6 root 2. So we're going to go and get rid of 6 root 2. We're going to take 6 root 2 from both sides. So if you're wondering what I'm doing here, I'm taking 6 root 2 from there, I'm taking 6 root 2 from there. So I'm going to get 12 sine theta equals negative 6 square root 2. Then I want to get rid of the 12, so I'm going to go sine theta, and I'm going to divide both sides by 12 equals negative 6 root 2 divided by 12, which equals negative root 2 over 2. Okay, now we have it into something that we actually recognize. Sine theta equals negative root 2 over 2. When does that occur? It occurs at that angle and that angle. If you look in your unit circle, that, and therefore theta is going to equal 225 degrees. Looking on your unit circle, you should be able to see that. Or 315 degrees. Now again, we're going to add k times 360, but instead of doing that, because we know it has to be between 0 and 720, I'm just going to add 360 to these until I get the right value. So 225 plus 360 gives me 585, and then I'm going 315 plus 360, and that gives me 675, and then if I add 360 to anything bigger than that, you're going to get over 360 degrees and over 720 degrees, and therefore that's the last one we can get. I'm not going to do this last example. Hopefully that helps you with the questions that you have to do.